What we now need to review is how to draw Lewis structures for elements that exist as diatomic molecules. So what a diatomic molecule is that it's a molecule that contains only two atoms. There's 7 different elements that when you have a sample of this element by itself, it doesn't exist as individual atoms. Instead, it exists in this diatomic molecular format. So if you have hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, or fluorine by itself, it exists as a diatomic molecule instead of as separate individual atoms. So for example, if I have hydrogen by itself, it exists in this diatomic molecule format where you have 2 hydrogens bonded together and then the formula will be H2. To remember the 7 diatomic elements, think of Hankelbrief. So that's hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. The key thing is when you're drawing a Lewis structure for a diatomic molecule of an element, you need to treat one of those elements as the central one and one as the outer one. So sometimes it's helpful maybe to color code which one is the central one or make a little kind of note underneath of it that this is the center, but then you just go through and follow all of your normal steps to draw a Lewis structure once you clearly know which one you're going to treat as the central one and which one you're going to treat as the outer one. To draw the Lewis structure for diatomic hydrogen, I'm going to start off by doing the inventory. There's 2 hydrogens, they each contribute 1 valence electron. When I multiply across, I get 2. I'm going to treat one of the hydrogens as the central one. I'm going to make it purple, and the other one as the outer one. I'll leave that one black. So I'm going to connect the outer one to the central one with a single covalent bond. That uses up all of my valence electrons. When I check, both hydrogens have 2 valence electrons. Remember, hydrogen is an exception. Once it has 2 valence electrons, it's done, it's happy, so nothing else needs to be done to the structure. There's 0 non-bonding pairs and 1 bonding pair. 1 times 2 gives me 2. That matches how many valence electrons I wanted in that Lewis structure. To draw the Lewis structure for diatomic bromine, I'm first going to start off by doing the inventory. There's 2 bromines. Each bromine contributes 7 valence electrons. When I multiply across, that gives me 14 total. I'm going to treat one of the bromines as the central atom, so the one that's in purple is going to be my central one. I place the other bromine next to it and I connect them with a single bond. So that uses up 2 electrons, leaving me with 12 still left over. Then I'm going to fill the outer shell of the outer element. That uses up 6 electrons, so I have 6 left over at this point. So I'm going to place those 6 remaining electrons as non-bonding pairs on the central atom. And now I've used up all of my electrons, so now I can check that central atom. That central atom has 8 valence electrons total. Therefore, I know that this structure is done. There's 6 non-bonding pairs and 1 bonding pair. 6 plus 1 gives me 7, times 2 gives me 14. That's how many valence electrons I needed in the structure. To draw the Lewis structure for diatomic oxygen, my first step is to create the inventory. There's 2 oxygens, they each contribute 6 valence electrons. I multiply across to get 12. I'm going to treat one of the oxygens as the central atom, so the one that's in purple is going to be my central one, and I place the other oxygen next to it. I connect them with a single bond. That uses up 2 of my electrons, so now I have 10 left over at this point. I fill the shell of the outer atom. I use up 6 electrons doing that, so now I have 4 left over. I'm going to place those 4 remaining electrons as 2 non-bonding pairs on that central atom, and now I've used up all of my electrons. When I check my central atom, there's 6 valence electrons, so it doesn't have enough. What I'm going to do is erase a non-bonding pair from the outer oxygen and create a double bond. Now that central atom has the correct number of electrons. It has 2, 4, 6, 8. It follows the octet rule. There's a total of 4 non-bonding pairs and 2 bonding pairs. 4 plus 2 gives me 6, times 2 gives me 12. That's how many valence electrons I wanted in this structure. To draw the Lewis structure for diatomic nitrogen, I start off by creating the inventory. There's 2 nitrogens, each contributes 5 valence electrons. I multiply across to give me a total of 10. I'm going to treat one of the nitrogens as the central one, the other one as the outer one, and I'm going to connect them using a single covalent bond. That uses up 2 electrons, leaving me with 8 left over at this point. I'm going to fill the shell of the outer one. That uses up 6 electrons, so now I have 2 left over at this point. I'm going to place those 2 remaining electrons as a non-bonding pair on the central atom, and now I've reached 0 valence electrons left in my inventory. When I go and check the central atom, that purple nitrogen, it has 4 valence electrons, so it's not happy. I'm going to go back to that outer nitrogen and erase a non-bonding pair and create a double bond. When I go back and check, that central nitrogen is still not happy. It now has 6 valence electrons. There isn't another location to make another double bond, so I'm going to go back to that outer nitrogen, erase another non-bonding pair, and create a triple bond. Now that central atom is following the octet rule and the structure is done. There's a total of 2 non-bonding pairs, 3 bonding pairs. 2 plus 3 gives me 5, times 2 gives me 10. That matches how many valence electrons I needed in this structure.